Thanks. Welcome back, folks. This time around, we are tackling the March 2025 question paper on wake energy and power. So let's check what we have there. An aeroplane is flying at a constant speed. So the moment we talk of speed, we know that power power is defined as force times velocity. Also know that work is force times distance cos theta, and power is also rate at which work is done, such that from this relation we are allowed to say work will be equal to power times time. Now, aeroplane is flying horizontally. The aeroplane's engines are producing a constant power of 5,500 kilowatts. So we put power, and we know that there is a force there of 25,000 newtons. Find the speed. I'm sure the formula of Newton is going to be this one, where we are saying power is force times velocity. So our power is 5,500 kilowatts, being equal to force, which is 25 kilonewtons multiplied by velocity. So we will divide both sides by 25k. Therefore, here it cancels, the k's will cancel, and our interest next will be from our calculators. V is equal to 5,500 over 25. Let me pick my calculator and see what we get from that particular calculation. It's going to be 5,500 divided by 25. Actually, it gives us 25. So, 220. So this is going to be 220 meter per second. Right. Moving on, the aeroplane ascends 300 meters. So the moment we have this, it's a height. So we can talk of potential energy, which is mgh. And what we know is work done is calculated as change in potential energy plus any resisting forces. Therefore, what do we have here? We are told resistance force is no longer constant, and the work done against the resistance forces in ascending is 270,000 kilojoules. Now, the mass of the aeroplane is 60,000 kilograms. Find the average power. So here we are interested in power. But remember, we said power can be calculated as we said power, because it's the rate at which work is done, is work per given time. But now from this relation, we know if we want work done, this is also power times time. So work done, which is what we have there, that's power times time. So I can come to say power multiplied by the time given there is 50. We are saying this is equal to change in potential energy, because we put the height there. So change in potential energy, that's M, which is 60,000, multiplied by G, which is 10, multiplied by 300, which is our height, plus all resisting force. So we are given a resisting force of 270 kilojoules, so 270,000 K. I'm proceeding with my calculation down. We are saying P times 50 is equal to, let's see, if I do the product above there, I'll bring my calculator and see what we'll get. Is what? 60,000. 1, 2, 3 multiplied by 10 multiplied by 300. Plus, remember we have 270,000, 270,000 kilo. That's another 3. This will result in 450 million. So I can come and say here I have 450 million. But because I'm looking for the power, I'll divide both sides by 50. And when this happens, my power is actually, I'll need my calculator again to divide the value that I have there by 50. So I'm dividing here by 50. My result is 9 million. So my power is going to be 9 million watts. If I want, I can rewrite it in a similar form, which is power. It's actually 9,000 kilowatts. So I think that's what we had for the March examination. Let's meet again in the November examination discussion. Thank you for